This video is regarding question 8.23 in the Cardi textbook. The question asks, for each of the following substrates, predict whether a carbocation rearrangement will take place in an SN1 or E1 mechanism. So with SN1 and E1 mechanisms, the very first step in both is going to be the heterolysis step. So SN1 is a heterolysis step followed by a coordination step. E1 is heterolysis followed by an electrophile elimination step. So both of them undergo heterolysis, and then with heterolysis, the intermediate that's formed is going to be a carbocation intermediate. And with carbocations, one of the things we have to look out for, and I always phrase it as being a red flag. So I usually, whenever we end up drawing a carbocation, I draw a little red flag, because one of the things we need to do whenever we have a carbocation present is to check for rearrangement. So what this question is asking is for us to look at each of these and figure out whether a carbocation rearrangement would take place when they're going through an SN1 or E1 mechanism. So the reason that we're talking about both of those mechanisms together is because they both have the same first step and have that same first intermediate. So just as an example, A has this present. So if we undergo heterolysis, I'm going to go ahead and draw the hydrogen atom in here so that we're keeping track of all of our atoms and not making any mistakes. So we end up with the chloride anion, and then this will now be a carbocation. So the question is, will this rearrange? Well, right now it's a secondary carbocation, which gets our methase. So we could do a hydride shift. So this was heterolysis. And when we do the hydride shift, we end up with a second hydrogen atom here, one that was moved over from that tertiary carbon. And now we have a tertiary carbocation. So A is one where, yes, a carbocation rearrangement would happen. For an SN1 or an E1 mechanism, because if we do have one, then it does, in fact, make a more stable carbocation. And if that's something that is possible, that's something that will be done. And you would just need to go through each one of these various substrates and go ahead, do the heterolysis step, draw the carbocation, and then see, would it rearrange? Would you be able to do either a hydride shift or a methanide shift typically? There are rearrangements where we can expand rings to larger rings, which makes them more stable. Would that occur to be able to make a more stable carbocation before the last step happens? And the last step will depend upon whether it's an SN1 or an E1 and the nature of the other reagents, the temperature, and other things like that.